Live from Chicago, welcome to the Chicago Python User Group, or ChiPy. Today is our September monthly main meeting, which happens on the second Thursday of every month. Thank you all for coming. My name is Joe Jasinski. I'm one of the organizers of ChiPy and will be your MC for tonight. We have a great meeting planned for you, but before we get started, I would like to cover our code of conduct really quickly. So the code of conduct is how we expect people to treat each other in when meeting in person and when meeting online. So please check that out on our website, and please just respect each other. So what is ChiPy? ChiPy is or the Chicago Python User Group. The Python, the programming language, not the animals. So that's the wrong user group if you're there for that. We're a Python-focused community. We started in 2003, and we've grown to be one of the largest Python user groups in the world, with several events each month and thousands of people on our various online forums, such as Meetup, GitHub, Slack, and our mailing list and various other sources. So ChiPy is run by a small group of board members who work on the big picture with ChiPy, but we have so many other volunteers and organizers that make all of our events happen that we couldn't possibly do without. So thank you to all those people, all of our organizers of our special interest groups and all the volunteers who work on our website and at the project night and mentorship that make things possible. We have several large initiatives with ChiPy. One of them is the Python Project Night, and this is an event where everyone meets up and works on personal projects or projects as a group. And because of COVID, we've had a slight hiatus for this, but we are looking to bring this back, and once we come up with some creative ways to make this happen in a remote capacity. Also, we have the Buddy Mentorship Program, which is a new program that we've relaunched kind of based on our old mentorship program, but this is where mentors and potential mentees can meet up together on a website and find people who are interested in similar projects and work as a mentor-mentee project together. So this is our new relaunched chipymentorship.org website. You can go here to find out more information. We also have a bunch of special interest groups. We have a finance SIG, a data SIG, a web dev DevOps SIG, and an algorithm SIG. If you want to find more information about various, if you want to dive deeper into various topics of ChiPy, this is one way you can do that. And recently we launched a new feature on our website called the ChiPy Job Board. So if you're looking for a job, or if you're looking to post a job, why don't you check this out, and hopefully we can match up job seekers with job providers. So a few Python community announcements that I found pretty cool. Python 3 related, Python 3.9.0, as we announced last month, is soon to be launched on, or it's soon to be available later this month. And next month is when the final release will be. 3.5.10 just came out. I'm glad they're still putting out patch releases for Python. Also, the Seaborn library released a major update. The Seaborn, if you recall, is a data visualization library. So they've done some cool things to make their API a little bit better, and general improvements. Pi Week, if you are into games and you're into programming Python, Pi Week is a week-long event where you compete to create cool games in Python. So if you're interested in gaming, check that out. Also, one of our own, Aly Sivji, who's going to be speaking later tonight, launched the WindyCityPython.com, which is a calendar of all the different cool events that are Python related that are happening in the Chicago area. ChiPy has a bunch of events, speaking of which. On October 1st, we have the Algorithms Special Interest Group, and the October 8th main meeting is our next big main meeting coming up. October 21st, we have the Data SIG, And as I mentioned before, the project night is hopefully going to be coming back soon. Stay tuned. If you want to get a hold of us, we have a big community on Slack. This is one way you can join our Slack channel. We also post to Twitter, so you can subscribe to @ChicagoPython. And if you don't remember anything from this talk, just remember that if you visit ChiPy.org, you can find all the resources I mentioned, links to all of them, and it acts as a basic landing point for all the different ChiPy-related resources. We've got a busy schedule tonight. We've got 3 great talks, which we will be hearing from our speakers very shortly. I'm really excited about that. And I'd like to introduce Ari from JFrog, one of our sponsors, to talk a little bit about a competition that we'll be holding.
Hey, Joe. Thank you so much. I really appreciate it. Hi, everybody. I'm Ari Waller, and I have the privilege of working on JFrog's developer relations team with a focus on meetups. And we're really, really excited to be one of ChiPy's newer sponsors. JFrog is an amazing software company founded in 2008 that is based in the Silicon Valley. We're best known for our DevOps products. So if you haven't heard of us before, you may have heard of our flagship product, Artifactory, which is the world's first universal binary repository. Today, JFrog has 600 employees and 10 offices globally, nearly 6,000 customers, and more than 3 million developers use our tools on a daily basis. Now, on the slide I want to refer to right now, one of the best parts of my job is my mission. And my mission is community happiness. It truly is one of JFrog's core values. And in the spirit of this, we want to give away something unique to a lucky attendee this evening. Tonight, one of the talks, as you saw, Kat Cosgrove from JFrog is going to be speaking about how her engineering team built a donkey car and did some really, really cool things with it. So tonight, someone's going to not only have a chance to watch it, but somebody will have a chance to build their own, as we're going to give away a complete donkey car kit that Kat actually designed the makeup of for us to give away. So we're really excited about that through the raffle. Now, you can enter the raffle through the QR code, and I'm actually going to put it in the chat in just a moment, or the bit.ly link for you to connect with. Also, even if you don't win the donkey car, there's still 5 of you that are going to walk away with a Iron Frog t-shirt like I'm wearing tonight. So try to make as many winners as possible. But with that being said, we're so excited to be here. So excited to give away a donkey car, and I'm going to turn it right back over to Joe so we can get the evening started. Thank you.
Thank you very much. Yeah. So a little bit about how tonight's meeting is going to work. We have a chat panel on the side. So if you want to participate, ask questions of the speaker, or just say hi, feel free to post to the Google chat. Just notice that there's a slight delay between the broadcast and your questions. So if you have questions for the speaker, please ask them, as best you can before they're done talking, so we reduce the dead air potential. And I'd like to get the chat started with a question for the night. So what is your favorite Python packaging or development utility? So what kind of tool do you enjoy using? Not necessarily as or for your development, but like to help augment your development. And the one that I would like to offer out there is I really like Python Poetry, which is a package management tool for Python. But I'd be curious to hear what all of you have to say. So post your questions or post your responses to the chat. And but that's enough talking for me. I would like to move on and introduce our first speaker. I'd like to bring Kat onto the stream. 1 second here. Hey, Kat.
Hello.
Let me. Thank you for joining us, and yeah, great to have you speaking. So for the audience out there, tell us a little bit about yourself.
Hello, y'all. My name is Kat Cosgrove, and I'm a developer advocate at JFrog. That means is that I used to be an engineer, but now I spend about half of my time still writing code, building demos, mostly proof of concept. So I never get bored. I don't have to write like enterprise production code anymore. And the other half of my time giving talks, teaching people stuff, writing tutorials, that kind of thing, which I really, really enjoy because before I was an engineer, I was teaching at a boot camp. Like at a coding camp. But before that, I worked as a database administrator at an independent video rental store. They are still open today. This is totally still a thing. For context on scale here, an average Blockbuster had about 600 titles in store at like peak Blockbuster popularity. The video store I worked at had like 46,000 when I left about 8 years ago. And I was responsible for the horror film department. Obviously, it was not possible to have any one employee be like knowledgeable about our entire catalog. So we had assigned genres, and mine was horror. So also very, very much into horror movies.
Very cool. How did you get into Python?
So I kind of grew up around coding in general. My dad's an engineer. My dad owned his own software company. And I was kind of always like vaguely exposed to it, but I got into coding the same way I think most people in their like 30s did, which is by having a super duper embarrassing GeoCities webpage at some point, which thankfully those servers have been like raised. So that those memories are not going to come back to haunt me. But I got real tired of my dad ragging on me for just being a web developer and only writing like, JavaScript. Because he does not believe that JavaScript is a real language, even though you can, write standalone applications in JavaScript now. He will not admit that it's a real language. So I picked up Python, which in spite of also being interpreted, he was much happier with. And I fell in love with it. And now I don't write JavaScript anymore.
A lot of us took that same route of not really regarding his JavaScript as a real language, but then they started coming out with then
Electron happened.
Yeah, Node and all that stuff.
Yeah.
So besides Python, what's your favorite language?
So I write some Go for work, and there are things that I love about it and things that I hate about it. I love that it feels a lot like writing C with a more Python flavored syntax. But I hate the way it behaves in some other ways, like, dependency management is kind of, has been a nightmare in Go until fairly recently. But overall, I do really like the language. I want to learn Rust. I think that's the language I'm most excited about right now. I just need the time to learn it, but it seems like a really, really cool language. So I really want to learn Rust.
Yeah, same here. That seems like a fun one. So we've all been experiencing like the effects of COVID. How have you been dealing with that and working through your day-to-day?
Well, before the shutdown, my job required a ton of travel. Like my last trip was at the end of February, and I had 7 flights between January and the end of February. So like I spend a ton of time on airplanes. Normally I'm home very little, which I enjoy. My husband has also gone a lot. So we've gotten very good at it. I miss airports, and I hated airports when I was traveling regularly. So I didn't think I would be at a point where I would say, God, I could really, it sounds great right now, standing in line for 45 minutes in security at Charles de Gaulle, even though I have, a known traveler number and every visa known to man. That sounds great right now. I would kill for it. And I hate Charles de Gaulle. It's my least favorite airport. But I don't know. I'm doing better than I was. Like 2 months ago, it felt like kind of like a fever dream, I was not sure whether this was a nightmare. I was depressed all the time. I was having a lot of trouble functioning, but now I think I've kind of gotten used to it, which is not good. But you know, it's different. I'm fairly certain that a lot of people are going to be struggling with crowd anxiety after in-person events resume, just because it's been so long since most of us have been around more than like 2 or 3 people at a time. But doing better. I hope everybody listening is doing okay at best. Please be doing at least okay.
Sharing your thoughts, and I guess now we're really excited to hear your talk. So I will hand it over to you.
Okay, let's get going.
Screen shared. Here we go. All right, take it away.
Alrighty. Here we go. So, thank you for having me, all. I've got to say, ChiPy is one of the cutest Python user group names I have heard. The one in Seattle where I live is called Puppy, and I thought that one was pretty cute because it's, Puget Sound Python. But ChiPy is also adorable, and I love your mascot. But welcome to Snakes on a Car, or Over-Engineering a Toy. Originally, this talk was just snakes on a car, like snakes on a plane, but it's Python, and I built a car. But the first time I gave this talk at the world's first Animal Crossing conference, I realized that what I had actually done was over-engineered the absolute hell out of a toy. So today I'm going to be talking about a miniature self-driving car that I built and the modifications my team made to it for a proof of concept. We almost entirely used Python for this. There's a little bit of bash scripting and a little bit of Helm in there too, but overwhelming majority of the cool stuff is Python, and you can build one of these too. Go. I already introduced myself in the pre-interview, but again, my name is Kat Cosgrove. I'm a developer advocate. And before I was a developer advocate, when I was an engineer, I was on the IoT team at JFrog. And we built a really flashy, really complicated demo to prove that updating the software on a car doesn't have to be as time-consuming and inconvenient as it currently is. Now, some cars can be updated over the air. I know you're thinking, oh, my Tesla or whatever. Yes, your Tesla can. A couple of other cars can, but the overwhelming majority of them cannot do it. And the ones that can, it still takes a couple of hours. You can't use the car while you're doing it. It's kind of inconvenient. And most cars do require you to physically take the car to a service center for the update. I have a whole technical talk on this demo. It's like an hour long and it's really popular, but there is not room in that talk for my favorite thing about the work I did on that team, which was building the miniature self-driving car, because it doesn't have massive market disruption potential. It's just we built a cool, fun thing and got paid to do it. But you can build one too. You can have as much fun as I did and maybe more. Before I get into the talk, if you would like to get a hold of me later, I'm on Twitter at Dixie3Flatline. If you know what that is a reference to, please DM me and I will send you a t-shirt, because nobody gets it ever. And I'm getting insecure about it and starting to wonder if this was too nerdy a deep cut, even for tech Twitter. So all of my slides and links to relevant resources will be at that bit.ly link, the show notes page, as well as a raffle for a kit to build your own donkey car. And we're also going to raffle off 5 JFrog t-shirts, the Iron Frog ones that Ari mentioned earlier. So let's go into the demo first so you guys have context. For JFrog's user conference last summer, we built a proof of concept demonstrating fast, reliable, secure, well, as secure as you can get, over-the-air updates for edge devices. And we used a car as our example because it's flashy. It's not something a lot of us think of as an IoT device or an edge device, even though it absolutely is. There's 4 or 5 computers in most of your cars, and you may be thinking, oh no, I know how computers work, so I don't trust them, which same, but your 2004 Honda Civic or whatever that you bought because it's super reliable, God, I miss mine. It's got computers in it. Braking systems have been fly-by-wire since like the 90s. So none of us can avoid it. But understandably, JFrog would not buy us a real car to potentially brick. So we needed to figure out how to build our own. Initially, we were going to just like build a dash infotainment system and put automotive grade Linux on it. But then I ran a hackathon and we decided that, like, why not have some fun with this? I will spare you the details since this isn't the talk for it, but we took updates on the car from something that could take hours and required physical access and flashing the device. Like Jaguar had to issue a recall like 2 or 3 years ago because they had a problem with the I-Pace, which is a very expensive electric SUV. To fix there was a problem with the braking system, a bug that was causing a failure in the regenerative braking system. And they had to issue a recall for this because they couldn't do over-the-air updates. So instead, we took that system and moved it to something that happens in about 35 seconds for an application level update, or 5 to 10 minutes for a full firmware update, both without interrupting the driver at all. It could, in theory, happen silently while you are driving. We don't think that it should, but it totally can. We had a pretty robust pipeline in place to make this happen, so everything was automated from the moment a developer pushed code. And this relied on a complicated network of JFrog tools and open source projects glued together with a bunch of Python scripts. Helm, K3S, Mender for the over-the-air updates, Yocto for our custom Linux distributions, and Artifactory for storing Yocto's build cache, as well as some other artifacts that were generated. I know that this is a gross oversimplification. It makes it sound easy, but I promise this is actually a shockingly difficult problem to solve, especially if you're trying to take into account things like differing hardware or network unreliability. So from a technical perspective, it was really cool. But it also looked really cool. I was so excited about this. We had a racing simulator set up in the middle of a big track, complete with pedals, wheel, screen, this like ridiculous racing simulator chair we found on Amazon for $300, and a green screen around the perimeter of the track. So this is me testing everything to make sure it worked before the conference floor opened. I would not actually recommend trying to like push code and drive. I was extremely nervous because we were letting random people interact with this demo, and they could do it in one of two ways: as a developer writing code and pushing updates to the car, or driving the car while someone else updated it. And I know live coding demos are always very risky, and we kind of took it to the extreme with letting people we didn't know who may be malicious write code in a live coding demo. But we were outrageously confident in what we built. In retrospect, a better word is probably hubris. It was hubris. So we really did let actual randos off the conference floor write code. Something only went wrong once early on day one. So it's not really a big deal. Fortunately, we got lucky. But here is what you need to build your very own miniature car, teach it to drive itself, and make some cool modifications so it's easier to use to harass your partner's roommates or pets with it. And when we go back to offices, your coworkers, which is what we use ours for when we're in offices. So let's start with the basics. Our car began its life as a donkey car, and these are pretty fun on their own. They're also fairly accessible for most people. They're less expensive than you would expect. I have one behind me, so I will grab it shortly. If you aren't familiar with donkey cars, and I was not when I first heard about them, which was at another Python meetup actually in Seattle, it's a miniature RC car that's been modified with a Raspberry Pi and a camera. The library that lets it do its thing is called Donkey. I'm not sure why, hence we call them donkey cars. And in its most basic form, you can build one for about $250 in parts. and a couple of hours of your time, assuming nothing goes wrong. If you want to try it for yourself, the show notes page for this talk has a parts list, but we are also, again, raffling off a kit if you go to the show notes link. So once everything is set up, you just record 10 laps or so on a track marked with brightly colored masking tape, or if you have a really dark floor, you can just put some printer paper on it. Anything that creates like super high contrast, because the machine learning on this is not very smart. Then dump the recorded images and steering data back to your computer and train a model. Donkey does come with a CLI that makes all of this as easy as possible. And the project itself is also pretty well documented if you want to dig in a little. It's also like the code itself is really clearly written most of the time. So it's pretty easy to figure out what's going on and dig around and make some custom modifications to it. These things are really, really fun, and a whole community exists just for modifying them with bigger batteries or more powerful motors and nicer wheels to race them against each other. The standard camera is just a regular Raspberry Pi cam, but some folks do add a second camera so that it has stereo vision or a LiDAR camera for better depth perception. Ours was a little beefier than the standard Donkey car since we were forcing it to do more work than it was built for. K3S alone would take up all of the available memory on a standard Raspberry Pi, I think. So we swapped it out for a 3B Plus with a compute module, which is what's pictured here. It also snuck into the office, because we're definitely still working from home here, and grabbed one. I don't have the battery in this one right now because it uses, this is the larger car, and it relies on a lithium polymer battery, and those are super volatile. And I did not want to have to deal with keeping like a fire safe bag and stuff in my apartment. So I left that where it belongs at the office. But yeah, it's just a 3D printed bracket on this wood board. That this bracket almost, it just exists to hold up the camera at the right angle. And this is the Raspberry Pi with a compute module. And that's it. It's fairly simple. You reroute the controls for the motor and the steering, this little hat here, and then you're good to go on the hardware side. Not that bad. Really, really not that scary. If you've never touched hardware before, I totally get it. Believe me, I do. This is a good way to get used to it, though. So, on to the updates. I am kind of extra. My hair and general appearance might tell you that. And we wanted a setup where the person participating in the demo as the driver felt like they were playing a racing game or something, some kind of racing sim, as close as we could get them. So this meant we needed to be able to control the steering with an actual wheel, which is not the way Donkey wants to behave to begin with, and the throttle and brake with actual pedals. So we knew we were going to have to make some modifications to the Donkey library. We also didn't really want to mess with manually dumping the images and steering data during a live demo either. Like, we did have 2 cars available, but it's a lot of juggling to do. It's just, it wasn't, we can automate this, automate the simple stuff, right? So we needed to fix that. We also wanted a TV screen in front of the driver's seat, the cockpit area, since, it's going to be driving in a circle and you need to be able to see what the car is seeing, or you're not going to know when to turn and you're just going to crash a million times. And since things were not complicated enough, let's just get some computer vision involved and put a green screen around the track too, because we didn't learn anything about feature creep during this proof of concept at all. On the controls, the standard Donkey car is easiest to control with a web app on your phone. That is how it wants to behave. That's how it behaves out of the box. It's not very interactive though, and it didn't give us the driving experience we were looking for. But the library actually supports swapping things out by itself. It calls its various moving pieces parts, and it actually did already have experimental support for a number of different physical controllers. These have been fleshed out more since then, but I have not personally tried them. The one at the time for the race wheel didn't really work like we wanted to. We had a Logitech G29 driving force as our race wheel, and I think that one was written for like a G27 or something. Logitech changed something about the way commands were passed from the race wheel, and it just did not interpret them the same way. There is some documentation on adding new parts, though. So we wrote one for the race wheel. We didn't try modifying the original one. We just wrote our own because it was easier. One of those starting over from scratch is easier than unraveling somebody else's code, because I think these are also contributed by just like random people. So the style is a little bit all over the place, and it was kind of difficult to tell what was going on at times. So this is a snippet of the race wheel part. It requires ZMQ and PyZMQ, and it works by requesting the current values from the racing wheel and the pedals via a ZMQ proxy running on the machine the race wheel is plugged into. In our case, we had an Intel NUC hidden under the driver's seat and a script running just using evdev to watch the race wheel. A whole lot of this demo actually ran because of that ZMQ proxy. It was doing some seriously heavy lifting. ZMQ's got a very strong back. And this is just a snippet of the wheel object on the car. It does also have methods for running threaded and polling for updates, but it is too much code for a slide deck. However, I am happy to provide anybody who asks with the complete part code if you want to swap out for a physical race wheel controller as well. Just ask, I'll send it to you. Once the part is added, swapping out the standard controller is a one-liner. You SSH into the Raspberry Pi on your car, open up manage.py, and add it as the controller instead of the default joystick controller object. It should be near the top of the file. So one-liner, hard to miss. However, to make the driving experience feel a little bit more like an actual car, we do need to do some processing on the values from the race wheel before they get sent to the car. The standard library does not really account for things like throttle scale or steering veer. You know how like the steering wheel on my Volkswagen it's very tight. It's very responsive. Same thing with the steering wheel on my Mini Cooper. But the steering wheel on the 1991 diesel Suburban, which was my first car, was a sloppy mess. And it felt like you pretty much had to turn the wheel fully like 8 times to get it to like take a normal left-hand turn. So the normal donkey library doesn't really account for things like that. And we need these 2 helper functions to do some math for us before sending the values to the car, or else the throttle feels really awkward and touchy and the steering is super jerky. We also allowed for customization of the force feedback on the steering wheel to make it feel like easier or harder to turn. Without this, you can still drive this thing. It's totally possible with the wheel and pedals. It's just a little bit awkward and it's unintuitive compared to the way you drive a real car. Because if you like press down on the throttle and then let go off the throttle, you would expect the car to slowly decrease in speed, but it does not. So we have to do a little bit of magic behind the scenes to make it behave in a way that's a little bit more natural. Building the driver's seat. The track is circular, like I said earlier, so obviously the driver needs to be able to see what the car sees, to know when and how to turn the wheel. It is also necessary, if you would like to use this to drive to the other side of your office and bang it into a coworker's door repeatedly when they ignore you on Slack, which is incredibly fun, and I very much recommend it. We also use it to harass our cats and try to herd them out from under the bed. To accommodate this, the NUC under the driver's seat needs to do a little bit more work for us. What we ended up with is a Sanic web server doing most of the heavy lifting for the back end. I had never used Sanic. I had never even heard of it, but I like it. It's very fast and very minimal. And then a Vue.js app for the front end. This was the first time I had written JavaScript in about a year, I think. And I also didn't know Vue, but I super didn't want to write React or Angular. Instead of storing all of the training data in a directory on the Pi, which is how it wants to behave by default, we instead reroute each frame and the associated steering data through the ZMQ proxy under a different topic. An async function subscribes to that topic, as well as a few other topics handling things for like our CI/CD pipeline, the racewheel data, and some other things required for software updates. And according to whatever the current customization settings are in the config file we were letting people edit, processes the data. At the bare minimum, the Vue.js app on the driver's screen is displaying the raw camera data from the car, the current builds, and buttons to record or upload new training data. I will not at any point in this talk show you the code for this because it's possibly the ugliest JavaScript I have ever written. I was under an extreme time crunch and I just needed to get it done. So it's not pretty and it was never intended to see the light of day, and I will take it to my grave. So sorry if you really, really, really wanted to see like the Vue.js equivalent of Frankenstein's monster, but it's not going to happen. However, it worked by using the JavaScript OpenCV bindings, which is a thing that exists, and an open WebSocket to just continually redraw the images from the camera topic on the ZMQ proxy to a canvas element. Pretty straightforward. At this point, the car itself functions the way we want it to, but it doesn't look as cool as it could. The driver doesn't have any nice scenery to look at, so let's stand a bunch of green poster board around the perimeter of the track and write the green screen that you can see here where we're driving through the desert. I will admit that this was not a part of the original plan for our proof of concept. It was feature creep from an executive who thought it sounded cool and maybe didn't understand how much else we had on our plate. I was very new at the time and riddled with imposter syndrome and very, very eager to impress my boss. So of course I was like, yeah, I can totally do that. No problem. Like I definitely know how to do that. I did not have any idea how to do this. Straight up did not know. I had to learn as I went. But it worked. And here's what it looks like if you have never written one before. In its simplest form, a script like this works by using OpenCV to read in a frame, convert it from RGB to HSV, which stands for hue saturation value, and create a mask out of any parts of the image that fall within a range of HSV values that you define. You then use that mask to crop the background image you want and replace the corresponding spaces in the original image. To get the etches closer to perfect, because your high and low HSV values are never going to be exact, you can erode and dilate the mask, maybe like blur and smooth it a little bit as well. You gotta fudge it some. There is a little bit of guesswork involved in finding the right high and low ends of your range, and lighting majorly affects it. So these help you kind of get there a little bit faster. Then just convert it back to RGB and return the frame. In this case, I am returning it as a string because of some other processing that's happening somewhere else that's expecting a string. Look, again, we built this in 3 months with 3 engineers, and we had a lot of work to do that wasn't just this like surface level flashy stuff. So we took some pretty extreme and in retrospect, embarrassing shortcuts. At least I did. Our green screen needs to simulate scenery on a drive though. So we could not just leave it static. The image has to appear as if you are moving, like as you drive past it. Otherwise, it's actually really, really disorienting. You could still drive kind of, but even if you were like consciously thinking about it, like aware that something funky was going on with the background and you knew what it was still really easy to miscalculate turning in a curve and crash into the wall. So we had to fix that. And to fix it, we used the current angle of the steering wheel and the starting X and Y coordinates to calculate how far we needed to move the area to crop out of the background from one frame to the next. We also used a scale variable to allow us to increase or decrease the speed of the pan, which made it feel like the driver was going faster or slower. But we ended up dialing that in pretty quickly, and people didn't really want to change that one. We did also allow for things like image filters and different backgrounds to be applied as some of the updates people could push, and these also took place within the green screen script. Things like going from the desert to the countryside to outer space, or inverting the colors or flipping the image vertically. All of these used functions that are already built into OpenCV, so there's no magic or hard work involved here. We got to deal with the manual training thing though. So we're going to automate that. In its current state, the process looks like this. You enable training mode to begin recording data, drive some laps, then stop the car, take the cover off, which is this like huge awkward plastic thing that makes a ton of noise, inconvenient. Dump the images and steering data into your laptop. Use the Donkey CLI to train the model, which is on a MacBook Pro. If it's a lot of laps, a lot of images, it could take a very long time. Like we saw it sit for an hour once, then manually move the model back to the car. It is a huge pain, and we don't want to deal with that. Automating the training was actually relatively low effort once we got over some hurdles related to TensorFlow on GCP. GCP has a product for this. They have a service for this. It's just a little bit wonky because Donkey uses like TensorFlow Lite, but it was transferable. Since we were getting the images and corresponding steering data from the car via our ZMQ proxy already, we just forwarded that data along to this tub writer utility we found, which is also running on the NUC. It collates the data for us, then passes it up to GCP to train the model there. And whenever a new model was available, the driver's UI would update to reflect the availability of a new model and allow the user to use that instead of driving the car manually, which people didn't want to do that often. Everybody wanted to drive the car. We really only had it driving automatically in between drivers or when we were taking a break or something. This was still pretty slow, actually. It took up to 10 minutes, but it's still faster and easier than the manual process of like stopping the car, moving the data, waiting for the model to train on a laptop, moving the model back, blah, blah, blah. At this point, there is pretty much no reason to stop the car at all unless you need to swap the batteries. And one of those huge honkin' LiPo batteries lasted all day pretty consistently. So that is how the flashy parts of our cool technical demo worked. Like I said, it's not really revolutionary, but it was super fun to build, and it's a great opportunity to teach yourself about hardware and machine learning, messaging queues, computer vision, all in one project. It's also really, really good for kids. If you can write Python like passably well, you can absolutely carry a kid who doesn't know Python through building one of these. And I think it would be a really cool project to do. If you have questions, you can also go ahead and start asking me those in the chat, because I will be sticking around to answer some. Personally, I did a ton of learning as an engineer while building this, and I hope you learned something from me talking about it. I cannot publish the entire code base for this demo because some of it is proprietary, but I can share the code for the components I talked about here. So if you build one of these and you want the race wheel part I wrote because you don't want to reinvent the race wheel, haha. Sorry. Or the ZMQ proxy or the green screen so you can build something like it yourself. Just let me know. I'm more than happy to hand that stuff over. If you decide to take a crack at it and have questions, ask me wherever. Again, I am also taking questions in the chat right now, but it's not like I have anywhere to be. So if you try to build one of these and you run into trouble, DM me on Twitter, shoot me an email. Happy to help you. And if you extend it even further and do some weird stuff that I didn't think of, I would love to see what you do. We did some cool stuff with this that didn't make it into the final demo. So there are definitely other things you can do with this thing. Tell me all about the experience. Tell me about the failures, especially if they're catastrophic. Again, my name is Kat Cosgrove, and you can get a hold of me on Twitter at Dixie3Flatline. You can also email me at catc@jfrog.com. If you have questions for me now, please go ahead and start asking them in the chat. And if you would like my slide deck or links to any of the resources I mentioned, like the parts list for building one of these, they are at the bit.ly link that you see here. Just a reminder, we are also raffling away one of these kits. So please enter. And even if you don't win the car, there is a chance you will win a t-shirt. Thanks for listening to me.
Thank you very much for that talk. Why don't you everyone give us give Kat a round of applause. So I have a question or two. You mentioned that you used K3S, a Kubernetes distribution for running on the car. Like how did you use that, or what was the purpose for that?
So, we needed a way to update the firmware on the car, and so that was part of what was handling that. The firmware on the car meant like the entirety of the car's operating system in this case. So K3S was what was making that a little bit easier for us, but also much faster for us. We had... It was kind of a rat's nest, to be honest, because it was 3 engineers in 3 months. So we didn't have time to do things the best way, but K3S was the best solution in this case for deploying all of the car's applications, microservices. Yocto, we wouldn't have been able to do it without Yocto either, which is building custom Linux distributions. So it allows you to do stuff like if your board physically supports both Bluetooth and Wi-Fi, but you're never going to need to communicate over Wi-Fi, Yocto allows you to build like a custom Linux distribution that does not include the module to support Wi-Fi. So it lets you get things as small as possible. And K3S is the smallest Kubernetes you can get. So we were short on space.
Let's see. I've installed K3S on my Raspberry Pi, but never found a use as cool as driving a car with it. So we have another question from Checkmate Kid. So I think you touched on this, but what web server did you use and why? Why did you choose Sanic for your server there?
So the web server was Sanic, and we chose it because speed was super, super important. Initially, we were using Flask, and instead of a 0MQ proxy, we were also just using like a REST API. And it turns out that HTTP calls take an eternity. And we were in a situation where milliseconds mattered because the driver was relying on the view from the car's camera to know when to turn. So we couldn't tolerate a delay of more than like 150, 200 milliseconds from the car seeing something to the driver seeing something. So we had to make decisions for speed wherever we could. And Sanic is just faster than Flask. It's also like really, really similar to Flask functionally, like from an implementation standpoint. So if you're already familiar with Flask, you shouldn't have much trouble transitioning to using Sanic.
Cool. Let's see. So you said you'd have people automatically live update, like program. How did you go about that? You said you were fairly confident in your approach. Yeah. So how did you do so?
Safely?
Yeah.
We had a very robust test suite for most things. But the number one thing that kept people from messing around and potentially breaking the car was that we had tried to get people to only make changes within this one config file. We had this one like big ass config file that had all of the things that you could possibly change. And this was done not actually to prevent people from being malicious initially. It was done to make sure that we were able to allow people who aren't familiar with Python or who aren't engineers at all to be a developer for a second. But what we found pretty quickly is that people were really uncomfortable navigating away from that window in the IDE, even though we didn't tell them they couldn't. Only one person tried to like go make changes elsewhere. And his changes actually didn't break anything because we had a very robust test suite. If any of the tests failed, it was going to fail the build and it wasn't going to get deployed to the car. So number one was, I guess, accidentally manipulating people into making them feel like they couldn't make changes elsewhere when they like totally could have if they wanted to. And then all three of us being like really anal retentive about testing. Just because we knew that if this thing burned down on the conference center floor in front of like bankers or like potential huge customers, we would be in some trouble.
So we have a question from Civ Scripts. Great use of Python. What was the one thing you would do differently if you had to do this project again?
We would have started earlier. Because like time was really a huge problem. We would have personally, I would have been much more comfortable saying no. If I had to do this again, I wish I had been more comfortable saying no. My tech lead did his best, but if I got cornered by an executive and he wasn't there wasn't really anything he could do to protect me from my own dumb mouth. So say yes less frequently. So, but from a technical perspective, I'm really happy with what we did in the time we had. Maybe I would have found a better way to handle the dashboard so that it isn't so ugly. There probably could have been some optimizing done there. Not ugly graphically, though it's not beautiful, but from a code standpoint, it's kind of a train wreck. So it's embarrassing.
Well, everyone, if we could give another round of applause. All right.
Thank you, everyone.
Yeah, thank you again for your talk. And now we're going to cycle into a 5-minute break, and we'll be back with 2 more great talks. So stick around, and thanks again.
Yeah, thanks.
Welcome back to the stream. We are about ready to bring up our next speaker. So I would like to introduce someone who needs no introduction from ChiPy, but we're going to introduce him anyway. Aly Sivji. Aly, are you ready?
Yeah.
Sounds good. So Aly is a board member on ChiPy and has been involved for a few years. And you might have noticed him for this stream and other streams on the ChiPy channel. So, but for the benefit of people who might not know you, tell us a little bit about yourself.
Hey, everybody. My name is Aly Sivji. As Joe mentioned, I'm one of the ChiPy organizers. You've maybe seen some like conference talks. But outside of Python, I like to ride my bike, go running, and just recently started playing video games again. So that's been a lot of fun.
Awesome. How did you get into Python?
So the first time I was introduced to Python was in 2008, 2009. I was working at an insurance consulting firm, and one of my mentors, he was talking about how we can use Python to automate a lot of our tasks. So I started just sort of seeing like learning a little bit about the language. The first script I wrote up was like back in 2009. Back then, Lollapalooza used to have sale for 3-day tickets for $50. So I just wrote up one scraper and I just checked that website, and I got myself and my friends really cheap tickets. But then I came back to Python, I'd say around 4 years ago, and been doing it professionally and loving it ever since.
Cool. Besides Python, what's your favorite language?
I know everybody loves to rip on JavaScript, but I'm actually a huge fan. I'm not really a big fan of like how there's unexpected behavior, but I don't think there's any other language that lets you experience the art of making things in such a fast way. Like you can just do something, hit refresh, and you're good to go.
Yeah, I mean, it's despite what I said before, I do think JavaScript is a pretty awesome awesome language.
The language of the world, man. The language of the world.
Not better than Python though.
Yeah, definitely not. Nothing's better than Python.
So, in this time of COVID, how have you been managing and keeping yourself occupied during COVID?
So I'm pretty extroverted, I feel, for a programmer. So it's been a little bit hard for me to sort of just be isolated at home. Fortunately, with our live stream and ChiPy and some virtual conferences, I've been able to connect with people. But it's also just been having conversations with folks I've not talked to in a long time. So just doing the best I can, spending my time learning, but also taking time for myself.
Cool. Well, are you ready to get started?
Yeah, let's do it. Let me share my screen.
Cool. Let me turn it over to you. And
I'm just going to do the entire screen because I know that works.
Sure. Okay, you got it. Okay. All right, take it away.
All right. Well, thanks, Joe. Can we also give Joe a round of applause? He's doing such a fantastic job. There's a lot of work that goes on behind the scenes, and it's like I know I'm sort of like up front and sort of seen more often, but there's a lot of folks that are not me that are doing a lot of work. So please just give him a round of applause, especially Joe. So we did have some fun with building a car. Now let's have some fun with some state machines. Let me get my pointer going. There we go. So my name is Aly Sivji. If you're on Twitter, I am also on Twitter. Please follow me at Kat Cosgrove. When you saw this title of the talk, I know you're probably rolling your eyes. Fun, finite state machines in the same sentence. Is this guy serious? I get it, but please just stay with me. So what's a finite state machine? A finite state machine is a triple M equals SAT, where S and A are non-empty finite sets, and T is a function that maps the product of S and A to S. All right, I already see a few of you dozing off. Are you seriously not having fun? Really? But you're not alone. I also find definitions like this very dry, and honestly, it's more than a bit confusing. This is how they introduce finite state machines in CS classes on the theory of computation. It actually leaves me with a lot more questions than actual answers. So let's get rid of all these mathematical symbols, and we're going to start again. A finite state machine is a model of computation. This means that when we're given an input, our machine produces some sort of output. Like the name implies, the machine can assume a finite number of states. This means that there's a limited number of states. It's not infinite or unbounded. And I want to stress this once again. The machine can only be in a single state at any given point in time. We can use transitions to change from one state to another state. And finally, the machine knows what to do because the current state determines allowed behavior. You can also think of finite state machines, or FSMs, as memoryless machines that make decisions based on the state they're currently in, and they don't really care how they got to that state. This is all probably still a little bit vague and confusing, so let's work through a real-world application so we can actually understand what's going on. We can model a light switch with a finite state machine. So here's the state diagram for a light switch. A state diagram, it's just a visual representation of a state machine. Our light switch, it's going to have two states, on and off. When the switch is down, that means the light is off. When the switch is up, that means the light's on. This light switch state machine can also transition between the various states. Flipping the switch up moves the state machine from off to on, and then flipping the switch down changes the state from on to off. This arrow with the dot indicates that off is the initial state of this FSM. To find out why these state machines are useful, it's best to work through an example. So going back to that state diagram, did we really need to model a light switch with a finite state machine? A light switch, it really only has two states. It has on, it has off. There's also a data type, the Boolean data type, that has two states, true and false. Could we model a light switch using a Boolean variable? Most definitely. I actually just watched the new Bill and Ted, so I've sort of got that in my vocabulary again. So here's what that would look like. So let's create a class. We're going to initialize it with the on instance variable set to false. Recall that when we create a light switch, the initial state is that it's off. Next, we're going to create a method. We're going to call it flip switch up. And here we're going to check to see that the switch is in the off position before we turn it on. We're also going to create another function called flip switch down. And this is going to check to see if the switch is on. And if it is, we're going to go ahead and turn it off. But what if we wanted to program a different type of light switch, a traffic light that has three specific states? Red means stop, green means go, and yellow means slow down. Or, well, it could mean speed up, really just depends on where you live. So how about we go start thinking about modeling a traffic light? Like before, we're going to create a class. We're going to initialize it with two Boolean variables. We're going to call it isRed and isYellow. And the initial state of a traffic light is red. So we're going to set isRed to true and set isYellow to false. Next, we're going to create a function called go. If the light is red and not yellow, we're going to set both instance variables to false. This indicates that since it's not red or it's not yellow, it's going to be green. The next function we're going to create is going to be the slow down function. And here we're going to check to see if both the instance variables are false. If that's the case, we're going to keep the isRed variable false, and we're going to change the isYellow variable to true. And finally, our stop function is going to check that the light is yellow before changing the instance variable to signify that the light has now turned red. Since we do have two Boolean variables, we're able to represent four different states. So what happens when both isRed and isYellow are true? What does this represent? Honestly, I'm not quite sure. We're going to have to sort of figure out what it means in our program. So I think this might be an indication that Boolean variables might not be the best way to represent these states. So let's change this up a bit. This time we're going to represent our state through a string. You can also think of this like an enum, but I really don't want to go into that. So we can initialize this new traffic light class with a string that it's red, that the state that it's self equals red, or self.red. And now when we have our transition methods, they're a little bit more readable since our states aren't things that we have to understand what they mean. before we go ahead and maybe modify this code for a different use. So far, the examples we've seen, they've been pretty straightforward. What if we have to model a little bit more of a complex workflow? How do we think about how do we think that we can go about doing something like that? Most of us were really familiar with GitHub and the concept of a pull request. So let's take a visualization of the pull request workflow. This is just another state diagram. Pull requests, they have 3 states. There's opened, there's closed, and then there's merged. When you first create a pull request, its state is opened. And members of your team can approve this PR or request changes. And both of these actions, they don't really change the state of this workflow. It's still open. Or if you look at it a different way, the transitions, approve and request changes, move us from the state opened to the state opened. We can also use the closed pull request transition to change the state of the PR from open to closed. And then we can use the merge pull request transition to change the status of the PR from open to merge. But I did leave one thing out. We're really only able to merge pull requests if they have at least one approval, or if the person making the merge has admin privileges. This is what this workflow looks like in Python. Honestly, it's really not that bad, but you can start to see that there's a little bit of complexity creeping in. And it's only going to get worse for workflows that have even more states or even more requirements around conditionals for transitions. A wise man once said that if statements are a code smell. So if you ever find yourself having to parse complex conditional logic to understand what's going on, it might be an indication that there's a better way to do things. So let's take a step back and talk about how we can go about implementing finite state machines in Python. So anytime I need to find an object-oriented solution, I go ahead and just go ahead and read my trusty design patterns book. Actually got my copy right over here. And so this book was written by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides. They're also known as the Gang of Four, probably because it's a little bit hard to say Vlasides. And this is one of the most famous books in software engineering, and it's for a reason. It contains a lot of tried and tested solutions to commonly occurring problems in software design. This book does have a section devoted to the state pattern, and it says that the intent of this pattern is to allow an object to alter its behavior when, sorry, let me say that again. The intent of this pattern is to allow an object to alter its behavior when its internal state changes. The object will appear to change its class since the behavior appears to have changed. And this is a picture I pulled from the book, just took a little bit of a screenshot. This is a bit of UML, and it honestly looks a lot more complex. So on the right, we're going to have our state interface, which has many concrete implementations. There's also a context class, which is going to interact with each of those. There's a context class that's going to interact with each of those concrete state implementations through their state interface. And looking at that Python implementation, there's this one sentence that stood out to me. It says that basically this is a state machine using objects. And honestly, I'm not sure if this is what we really want. It sounds like we're going to trade a bunch of hard to read conditional statements in a single class, and we're going to change them for just a bunch of different classes. I'm not really too sure that trade-off's worth it. It might make sense if our objects are polymorphic, but I really don't think that makes a lot of sense for state machines. So let's take a look at some of the popular Python state machine libraries that we can find on ChiPy. So the 3 most popular libraries I found when I was first doing my search are Transitions, Automat, and Django FSM. So let's walk briefly through these by just examining their quick start. I'm going to be going through this material fairly quickly. I'm going to provide links so you can go ahead and see the documentation in more detail. So don't worry if you can't follow along. You can check it out after this talk. So for transitions, what we're going to do is we're going to create a dictionary configuration of all of our states, and then we're going to initialize a machine object. Oh yeah, okay, there we go. And now that we can view the states, now when we have this object, we can actually view our states and go into a different state. And this is good, but I really don't like having my configuration set up in a dictionary. It sort of feels like I have my configuration separated from my implementation. With Automat, what we can do is we can use decorators to mark our states as well as our inputs and our outputs. And then we'll have to specify transitions using the upon function. And I really like this idea of using decorators, but it still seems like it's a little bit complicated. Like our implementation and our configuration, they're not exactly in the same place. So Django FSM is the last library we're going to talk about. This is a state machine library that's built on top of Django. It's going to add a state column to one of your Django models. So what we're going to do is you're going to create a new database field of the type FSM field. And then you can specify transition decorators with information like source state, target state, the conditions that need to be true for this transition to actually go through. You can also specify error states for when your transition function raises an error. I absolutely love this API. It's really clean. It's really easy to read. And when you look at your models.py file, if you've never actually dealt in this code base before, you really know what's going on just by reading the code. There's also an audit log tool that's built around Django FSM. So anytime your state changes, it's going to send a signal that's going to be captured by this library. And it's going to be able to save that to your database so you can actually track all of your state changes. And when you're designing web applications, that's one of the hardest things to figure out. Like, how did this object get into this particular state? Or how does this database record get into that state? And I'm going to say that Django FSM is my current favorite library. It's not really specific just to Django. I think this is like my current favorite Python library that I'm using like across all of Python. But the only problem with that library is it's built specifically for Django. So I spent a couple days over the past 2 to 3 months, and I created Finite State Machine. So let's take a look at how this particular library works. So going back to that GitHub pull request workflow from earlier, we can implement this in Finite State Machine as follows. We're going to start off by creating an importing state machine and transition. Next, we're going to create a GitHub pull request class, and this is going to have state machine as its parent class. In our init function, we're going to need to set the instance variable for state. So here we're just setting the initial state to open, and we're also just setting some other instance variables that we need for this particular workflow. And then in our transition functions, we can specify all of our side effects. So if we want to say add a number of approvals, if one person just approves your pull request, we can do that there. If our transition function has to deal with complex conditionals, we can just specify them as functions inside of our list. So let's just do a code comparison. This is what our initial state machine looked like. And this is our implementation using the Finite State Machine library. I really just think like you have your implementation, you know what to see. It's using decorators. It just makes things a lot more useful. But that's not all. The statement diagrams that we did see earlier, we were able to generate them using a command line tool that's packaged with this Finite State Machine library. So if you're interested in using this library, you can pip install it from the Python package index. And if you want to see how to use it, check out our GitHub page. There's a quick start guide along with some example workflows. So I do have some caveats. This is just a really lightweight library that implements the behavior of a state machine or a finite state machine in Python. The main state machine logic in this library is less than 60 lines of code. I'm not really doing anything crazy or anything unexpected. This library just does exactly what it's supposed to, nothing more, nothing less. I use this library currently in Busy Beaver, which is the Chicago Python community engagement Slack bot. You're really free to use this library in your own projects, but please use it at your own risk. And if you do use it, I recommend reading the source code. Again, it's only less than 60 lines. And I would say this is pretty standard advice. If you're importing something into your own project, you should try to read the code. I know like it doesn't happen. Like obviously I don't do this. Like I have not read the Django source code, but you should at least try to make an effort to get familiar with the code that you're going to be using and you're going to be depending on. And one last thing, if you're using Django, don't use this library. Like I just copied the API from a much better library. If you're using Django, go ahead and use Django FSM. So here's a list of resources I used to first learn about finite state machine and then to come up with this talk. I put stars next to my favorites. You should really just go check out those videos by Calvin Hendricks Parker, who is one of the organizers of IndiePy. Shout out to Calvin. And Harrington Joseph, who gave a talk at Pi Texas about transitions. Both of those are fantastic talks, and you're definitely going to learn a lot. So that's it for me. Thanks everybody for your time. If you do have questions, please put them in the chat. I do want to give a shout out to this fantastic organization. Like 4 or 5 years ago, I was not a programmer. I was working more as an analyst, doing a job I really didn't like that much. And Chicago Python really helped me get to where I am right now. So thanks again, everybody, for your time. Yeah, I will take your questions.
Thank you very much, Aly. Let's give Aly a round of applause.
Thanks, everybody.
So, quick question to start off. What class of problems do you find most useful for finite state machines? Like, when would you use that? When would you pull that out of your toolkit?
Yeah, that's a great question. So they say that every single thing in computation can be represented with a state machine, and that's definitely true. But I think the things that I use it for are mostly like workflows where I have to store some state to the database. So even when I'm using this like finite state machine library, the reason I'm using it for Busy Beaver is like I'm using Flask behind the scenes. So I just wanted a way to make my workflows a little bit more explicit. It's also useful if you ever need to build out an audit trail. Another way I've used it is to, I created a couple of plugins for this like hardware device called the Elgato Stream Deck. I was gonna be like the way the plugins I create work is you have to create like a WebSocket server and communicate. And I'm thinking 2 different processes. Like I'm thinking a process on my Mac along with something on like talking like via like WebSockets. So I'm actually using a state machine to make sure that things are not getting out of sync. So it's really good for like asynchronous type of workflow.
So what's your next step with that library? Do you have any future plans for it, or?
Yeah, that's a great question. So I'm trying to get it as feature parity to Django FSM as makes sense for the library. Like right now, we're not able to use enums, so there's an issue like in the GitHub repo to add support for enums. I'd also like to add support for available actions. So when you're in a specific state, what actions are you able to do? And this is something I've really found useful when I've been using Django.
Cool. Let's see. I don't see any more questions. Do you have
a great job explaining all of this? Like I'm sure people are fast asleep.
No, it was a very good, concise overview of that. I really thank you very much. Let's have everyone else give Aly a round of applause again and thank you again for your time.
Thanks so much, and I'll see y'all later.
All right, we're on to our last speaker. Let me bring him onto the stream real quick. Hi, Dave. Why don't you tell us a little bit about yourself?
Sure. My name is Dave Trollope. I'm a senior software engineer at Knowledge Hound, and I was born and raised in England, but I moved to Chicago just over 20 years ago, and have stayed here and have enjoyed the cold winters and the hot summers compared to England. So, outside of Python coding and Knowledge Hound work, I like to spend time in the garden. My wife and I are both avid gardeners. And I also like at Christmas to do a bunch of sequencing for Christmas lights and programming different sequences with mega trees and other things. So that's always a fun distraction from actually coding.
How did you get into Python?
So I did not know Python really before I started at Knowledge Hound. I had dabbled with it a couple of times through my career, but not seriously. And then when I joined Knowledge Hound, it's the standard language that is used for the back end. And so I ramped up on Python as part of joining Knowledge Hound and starting to maintain the applications there.
Cool. And aside from Python, what languages, what's your favorite language?
Yeah, so besides Python, I was using Ruby in my previous job. And I have to say, I really enjoyed working in the Ruby ecosystem. It was a Rails ecosystem. And so it was also easy for me to sort of map the Ruby Rails sort of mindset into the Python Django type world, which Knowledge Hound is using. But I do find just some of the fluidity of the Ruby language is sort of fun to write in. So that's my alternative go-to language if I'm playing around with stuff.
Cool. And in this day of COVID, how have you been managing? Like, how have you been keeping yourself busy and distracted?
Yeah, so the transition to working from home, has been, good for me. I used to ride the train to go to the office. I'm actually about 35 miles outside of Chicago, and my daily routine would be to walk to the train, get on the train, and then ride to the office. Clearly, that will stop. So I'm using my study a lot more. Now, what's funny about this is back in December, my wife and I decided it was finally time to actually redecorate our study, get new desks, new furniture, make it a more sort of comfortable working environment, which we'd been saying that we were going to do for probably 5 years. And we just said, okay, now's the time. And little did we know how important that was actually going to become come March. So now I have a pretty comfortable environment to work from home in. And so that's been pretty good. And, as I mentioned, like to work in the garden. And so that keeps me, sane when I'm working outside. And of course, it's been so dry over the last few weeks. So I've spent a lot of time outside on the weekends in the fresh air. So,
yeah, I've definitely also been upgrading my desktop at home even before, and was happy that to have a space to work when we were forced to work at home. So anyway, thank you again for talking. Let's get you set up with your screen share, and you can take it away.
Yeah. All right. I'm just going to share my whole screen like Aly did, because I know that's easy and should be seeing the presentation now. Yeah, here we go.
Great. Take it away.
Okay, so I wanted to talk about a couple of examples where in the last sort of 6 months, Knowledge Hound has had to sort of reinvent some of the way we do things. And a couple of examples which remind me as an engineer to not always be beholden to the tools that you know and use every day. And I have a couple of specific examples here that I want to walk through. So the first thing is, we all know and love pandas, right? It's a fantastic library. We use so widely in the Python, ecosystem. And at Knowledge Hound, what we do is we build a data analytics platform for survey data. And so over the years, we've built this backend that actually serialized Panda data frames and stored those raw blobs in the database. And we would, on demand, as we're doing data analysis in our UI, read that data, run whatever analysis we're doing, filters, queries, cross tabulations, those kind of things. And, it was good. But, that's always good. We know Pandas is always fast. And, as somebody who came to Python, I've always been like, Python's a bit slow as a language. And, I've always had that bias. And so it's like, okay, we'll just always go to pandas. I mean, pandas is written in C, so it's got to be fast, right? And so we built a new backend endpoint that was fetching data, transforming the data after we pulled it from the database. And because we moved from serializing the data in Panda data frame in the database to just raw flat tables. And so we started reading the data directly out of the database, loading it into a Panda data frame, and then transforming it into a form that we wanted to use. And as part of this long workflow for fetching the data, we came across this fun loop that we built. And it's like, okay, this is a nice, simple thing. Like it's 1-2 lines of a comprehension. That's not going to be a performance problem, is it? Well, when you break it down and actually look at the details, it's actually doing quite a lot. That one line is filtering the interested permutations of all the data that we're trying to do analysis on. We're trying to drop all the nans. We're selecting the first column, and then we're summing the result. And it's like when you conceptually talk through what it's actually doing in basically that one line, that's a lot of operations. And we originally built this using a multi-index column. And it's one of the cool features of pandas that one of our newer engineers had introduced us to. And we started looking at this and realized that this one loop was taking nearly half a second to run on a fairly basic data set. And so we started to do some analysis on it and try and improve the performance. And I did some research, Googled Stack Overflow, found some old references to potential performance problems around indexing through a multi-index column. And so I was like, oh, let me just experiment and see if I can flatten the indices into a single index and just see what happens with the performance. And amazingly, as you can see, we went from 494 milliseconds to 158 milliseconds. And that includes copying the data frame. So it was like, okay, that's fantastic. But this is an interactive UI that we're doing. And of course, there's a lot of other processing that has to happen once we receive the data. So 158 milliseconds is still pretty slow. So we needed to get it faster. So I started to look at that loop and that iteration. It's like, well, what's actually happening between Python and pandas? We're dipping in and out every time we iterate to Python, to pandas, and transferring a lot of data. And it's like, is there a better way? Is there some way we can eliminate some of those transfers? And we started to sort of just play with lots of different alternatives. And I posted in the ChiPy Slack, got some ideas from people there. Appreciate everybody that was involved in the conversation and contributed ideas. And then I was like, I'm not really getting anywhere. I'm not really making great inroads to the performance. And so I was like, well, let's just try writing this in Python and see how bad it really is. And I was a little shocked. Yes, it's a lot more code, as you can see. Instead of the one line in a comprehension, it's a lot more complex. But when we ran it and when we performance benchmarked it, it comes out that doing one extraction, essentially, and then processing the data in Python, we got it down to 11 milliseconds. That's from 494 milliseconds down to 11. That's huge, just in that one loop. And so that was when I was like, well, why is that? And I think what we always forget is the standard library in Python and the dictionaries and standard types. There's a lot of C code that has been highly optimized because it's used a lot. Every Python application is using these. And so the optimization level is huge. And because we're not dipping in and out of pandas as much, it becomes very fast. And in this case, I'm using some set math. And that's where the performance benefit comes from. And so my conclusion here is to sort of make you, when you face a problem and you're starting to run up against roadblock after roadblock, to just rethink your assumptions about what tools you're using and why you're using them. Because it's so easy to just say, oh, this is what we always use, and keep using it. In this case, we stepped back, just rewrote it in pure Python, and had a huge, huge performance gain. So that's one example. Bonus material. As part of doing this benchmarking, we actually created a very simple context manager that allowed us to wrap any piece of code with a simple measure, and then we would get the data from that code block and reuse it across multiple sort of different pieces of code. And so what we actually did was run the same code linearly, and then we could get an old versus new comparison on every interaction that we did on the server with that data. So pretty cool. I'll get these slides shared, and people can reuse this if they want. So on to our second one. The second answer is, well, we use Django to build all of our applications in the back end at Knowledge Hound, and we've traditionally done that. But the new queries that we're doing to pull this data out was designed to use SQL and Postgres' array ag. And we're really trying to put more of the power of the database into our application so that we don't have to do as much processing in the application. And so we had a query like this, which is an actual nested query using array ag, and then we're grouping the responses. And so it's like, okay, this is where Django is a little more challenging to do this type of query. It can be done. Unfortunately, we're on an old Django 1.8 app. And yes, we are upgrading from that. But what I did was I was able to actually port back from Django 1.10 an array ag class that got us to implement this. But we ran into another problem where every piece of data that we have to pull, the data has to be weighted. And we support arbitrary weightings. And that means correlating two different tables in our models that don't have foreign keys. And this is where Django really started to sort of get in our way, because that's really difficult to actually query data through two tables without a foreign key in Django. And so it was like, yes, I could probably find a way to do it and invest the time to understand how to do it in Django. But as an alternative, we said, hey, maybe we just need to use a different tool. And so we chose to use SQL Alchemy, and we used the core API. And we thought, well, we'll give this a go and see what it's like. I've never used SQL Alchemy, but one of our team members, again, had used it in a prior job and said, yeah, we can do this. Now, of course, right, what's the pros and cons here? We could use Django, we could use raw SQL to write this query, get the data, transform it. Or we could use the APIs in SQL Alchemy to actually make this query. And the code is probably going to be cleaner. But one of the big questions was, okay, it's a Django model. How is Django and SQL Alchemy going to work together? Will they compete? How do we manage the migrations of the model in Django and then have SQL Alchemy query it? So there were lots of questions. And what we ended up doing was we used the SQL Alchemy core APIs to do the actual query of the data. But we built an introspection that allowed us to actually pull the Django model metadata to define the table in SQL Alchemy. So that means, hey, we can still use Django to manage the model and generate the migrations, and as we make changes, use Django. But we don't need to constantly update the SQL Alchemy schema because it will automatically happen at runtime. The only real conflict that we ran into was in tests, where because we were using the standard test case and everything's running in a transaction, we would not be able to query that same data because it was stuck in a transaction. and we switched our tests to use a transaction test case, which actually allowed us to have SQL Alchemy create a second connection to the database and query the test data that was being used in that test and generated from Django. And so we got the best of both worlds. We had Django's great management of the ORM, but we also had the raw power of basically writing SQL in a more Pythonic way. And so that's ultimately where we landed. And a second reminder that we had never thought about using SQL Alchemy at the start of the year. And it's really important, again, to step back, think about the problem you're facing, and ask just, are there other tools that we could be using? And spend some time to actually, prototype them and see if there's a viable alternative path that ultimately will get you a simpler solution. And in that vein, another bonus piece of content here, because my laptop is running all of these applications, and I'm running multiple VMs, and I'm running Docker, and it's a MacBook Pro that's a couple of years old, it really struggles. And so every day, especially working from home and working remotely, we're on video conferences with everybody on the team, and the streaming gets kind of jittery, and it's because my laptop is overwhelmed with all the things I'm trying to get it to do. And so what I ended up doing was reassessing, why am I joining with my laptop? I have an iPad that I use every day. I always join from the iPad because I get a more reliable streaming through my iPad. And then when I want to present something, then I actually just use the laptop to present and share my screen. And that way I get a much more reliable, stream of video and audio, and the meeting is a lot more fluent. And so again, it's a question of a reminder of how do you actually look at the problems that you're facing and find alternative tools that actually do it better and simpler. And of course, it's always easy to just rely on the tools that we have to hand and use every day. But quite often, the solution to your problem is to actually just use a different tool and take the time to figure out if it's a viable path. And that's the message that I want sort of people to think about next time they're struggling with a problem. It's like, step back and ask yourself, is there an alternative? Use the knowledge of your teammates to figure out if there's another tool that they've used that would actually make your problem simpler to solve. So that's it. That's what I really wanted to say. There's a couple of references to the core API for SQL Alchemy and some of the other articles out there on the web relating to sort of mixing Django ORMs with SQL Alchemy. And of course, I stole the Python pandas image for the presentation. So there's a link to it. So I'll be happy to answer any questions.
Thank you very much. Let's give Dave a round of applause.
Thank you.
So I'll get started with the question. So there's, part of when you're working on a particular approach, there's like a sunk cost fallacy. Like, you're maybe focused in on that that approach, and when do you think it's time to not give up, but broaden your horizons and maybe learn something new when you know that it's going to take a while to get absorbed in that new thing?
Yeah, so I think there's two important parts to that. Is one, when you're really facing a problem that you're getting frustrated with, you feel like it's the only way to do it, I think you have to ask yourself, stop yourself and ask yourself, is there an alternative way? And then the next question becomes, okay, if there is an alternative way, how much effort do I think it's going to be? And one of the problems that I think a lot of people run into is they start thinking of the alternatives and how complex those alternatives can be. And I think it's a bit of a skill to step back and say, okay, SQL Alchemy, for example, does lots of things. but really trim down to what is the most basic need that I have, and forgetting all of the icing and all the nice to haves that comes with a big framework like that, what's the one small thing I want to do? And if you can prove, in a time-bounded exercise that that can work in some raw form, then you can make the decision that, yes, this is a viable path or not. And even if it takes you a couple of hours or a half a day, if you get a positive solution, it's going to save you hours and hours on your project. If it doesn't yield a solution, and sometimes you do those investigations and it's like, no, that really wasn't a good idea. What was I thinking? What have you lost? You've lost a couple of hours, but you've probably also learned something in the process that you might be able to use on another project when you're facing another problem. And so you haven't really lost anything. And in terms of your project, yeah, you've lost a couple of hours, but you've learned something in the process, and you've validated that your original path is actually the right one. And hey, maybe I do just need to grind through it.
And another question. So you've spent some time with both the Django ORM and SQL Alchemy. What's now that you've had that experience, what's your, experience, or what's your pros and cons of maybe using both? Or
yeah, so it's interesting because SQL Alchemy actually has a high-level ORM API as well as the core APIs. And what we ended up using was the lower-level core APIs. And this is really good because the code is literally like writing SQL. You're specifying the table, specifying a select, you're specifying the joins, and it really is a wrapper around SQL. Really good for low-level performance queries that are just really specific. But I will still always come back to Django ORM just because of the schema management, generating migrations, the ease with which you can write a model and generate the table and the migrations and just manage the models as a whole. And so I think it's a really good pairing. What I don't have an appreciation of right now is I haven't used the SQL Alchemy high-level ORM, and so I can't sort of compare the Django ORM to the high-level ORM. I'm not really an SQL person or background, and so I prefer Django from a high-level database model just because I've learned how to query across data in Django, and I think it's simpler to write than if you try and do it in sort of SQL. One day I will get to learn the SQL Alchemy higher level ORM, and then I'll be able to make a real comparison.
And one question regarding your, you mentioned how you introspected the ORM or the tables. So I was curious, did you use the SQL Alchemy reflection API, or did you build something to actually consume the Django model at Python level and generate the code that way?
Yeah, so the code to do the introspection is in the slide. And so we literally just got the table name out of the Django model metadata. And then we used SQL Alchemy's metadata class to get a meta object. And then we just created a table object based on the table name that we'd pulled from the Django model. And the rest was done, right? There is no other sort of code to introspect. It's literally get the table name. It discovers and auto-discovers the fields. So that was, no real complexity there at all.
Cool. I don't see any other questions. Let's all give Dave a round of applause. Thank you very much. Thank you very much for joining us. And is there anything else you want to mention before we end?
Just to reiterate that I will get my slides, either shared on the meetup. You can also email me at dave@knowledgehound.com, and we will be posting the slides on the Knowledge Hound website as well.
Great. Thanks again, and I really enjoyed the talk.
Thanks.
So that is ChiPy. Thank you all for joining us. And I'd like to thank all of our speakers. We had some great talks today. And thank you also to Aly for helping out with the stream, and to our sponsor, Ari or JFrog, and Ari from JFrog for helping make this possible and producing this raffle. So if you enjoy the ChiPy channel and want to hear more ChiPy talks, we have a lot more coming. So please subscribe to the YouTube channel. And otherwise, have a great day, and see you next time.